In our quadratics unit, we talked about finding the minimum and the maximum of the function. Well, that's all well and good if you have a quadratic and you only have one relative minimum, relative maximum. But what if I have a function that looks like this? And my cubic functions sometimes look like that. Well, in this case, I've got both a relative maximum here at the top of this mountain, where all of the points to the left and the right are lower than that value. So we call it a relative maximum, top of a hill. And I have at the same time, a relative minimum where all of the function values to the left and the right in its immediate vicinity are higher than it is. So we call this a relative minimum, a bottom of a valley. Well, we can find those on our calculator. Remember we talked about when we were graphing that we didn't necessarily know how high or how low those hills and valleys went in our function, but I can find that exact value, or at least the decimal approximation of it, using my calculator. So let's use the function f of x is equal to x cubed plus 3x squared minus 24x. If I graph this on my calculator, then I get a function that sketches like this. This is kind of what it looks like. Not perfect, but basically what it looks like. If I want to find the value of this relative maximum and this relative minimum, the easiest way to do that on my calculator is to press the second key and then the trace key. And remember that above the trace key it says calc. And then choose maximum if I want a relative maximum value, and choose minimum if I want a relative minimum value. Now, remember, it's going to ask you when you do that, left bound and right bound. So if I am looking for this maximum value right here, I'm looking for that. When I do second calc maximum, I'm going to need to put my left bound over here somewhere and my right bound somewhere in this area. So I don't want to come over here. I don't want to come all the way over here because guess what? I have a value out here that's higher than the value at the top of this mountain. I'm looking for a relative maximum. And then my guess would be somewhere in the vicinity of that point. What we will find when that happens is that my maximum value occurs at the point negative 480. So what we would say is that the maximum is 80 at x equals negative 4. So I have a maximum of 80 at x equals negative 4. Then if I come back and I do the same thing and I find the minimum, I'm looking for this value right here, my relative minimum at the bottom of this valley. So second calc minimum, my left bound has to be somewhere over here. Right? I can't get over here because if I get over here, then I'm going to get a point in this section. So I'm going to have a left bound, then somewhere in this vicinity, a right bound, just left and right arrow, and then my guess is going to be here. And it's going to tell me that that relative minimum is at the point 2, negative 28. And remember, your minimum maximum is actually a y value, and then we say at x equals. So my minimum here is I have a minimum value of negative 28 at x equals 2. So I have found the relative minimum and maximum for a function by using my calculator.